In the recordings, I am sorry we had some technical difficulties, but we picked back up. All right, so I'm on the last section there. Any other questions? 31, sorry, I didn't hear you. 31. Power trig argument. There is no power. What's the derivative of cotangent? Secant tan. Do you just remember that? Secant, but here's where it's a little bit harder. Secant of the argument, tangent. Oh, Wyatt.
Oh, good job, Wyatt. Remember that.
I just went right. I don't know the colons. I have to, if I, let me tell you why. Let me tell you why, and you can do this also. I would change this to cosine over sine and do even more work, but I would do the question on that because it's time. That's what I do. So no, I don't remember secant. I remember secant because it comes up so much, but cotangent and cosecant, I don't. Okay, what's cotangent? Negative squared. Now times the derivative of the argument, times 3. So there you go. It's good math to move it though. Dozier, we have work number 3, 5 different times. Oh, okay.
Yeah, that's right. Yeah, that's right. Keep going.
Second derivative, power. Negative 6 cosecant 3x minus 1. Now the derivative of cosecant, which we said is what? Well, no, cosecant, because we did power, now we're doing trig. Derivative of cosecant is what? Negative cosecant. Cotangent. Now the derivative of the argument. Times 3. I would definitely. What you mean? Yes. Yes. So now I would definitely clean this one up a little bit because these are the same. Yep, it's positive. I've got cosecant squared 3x minus 1 and cotangent 3x minus 1. Cosecant squared cotangent. Be kind, Logan. I said be kind. What? Yeah. Huh? What was yesterday? That is disgusting. What else? What else? 29. All right, lock in, guys, lock in. Derivative of tangent is secant squared. So the second derivative. So this is what I'm going to do. Power trig argument, right? 2 secant x. Now what's the derivative of secant x? Secant tan. And the derivative of x is just 1. So I've got 2 secant x's and 1 tangent x. I know. She said she didn't quite understand where we got it from. There you go. There you go. 21. Oh, that is right. It is differentiable. First one being F, the second one being G. I just really didn't know I could do this. It is cool. Look at here. Yeah. Okay, so let's work through these because you have one like this on your homework. Guys. If I add them together, is it how would I do that? Find where -3 is. I should not be in the same color as the.
1.5.
So at -3, I'm at -1.5 on F. Where am I on G? -3, -2, right? And I can just add those together, no problem. Do we agree? Yes, I am. How about, what happens if I ask for, though, the derivative? That's exactly right. I'm looking at the slope of them. And so I might, since these are all lines here, I would go through here and just say, okay, here I know the slope is what? Up 1, 2, 3 over 2, 3 over 2. If I go from here to here, that's up 3 over 2. That's right, my triangle. This part, what's the slope? Down 1 over 2. So -1/2. Are y'all following me? Because they're asking me for the derivative, and so derivative is slope. Just to help me as I go through this problem, I was just going to go ahead and mark the slopes out to kind of help me here. How about this line? What's the slope? 0. How about this one? 3 over 2. I'm going from the first point that I can really define up to the next one, and so to get from one to the next, 3 over 2, yeah. All right, so now if I want to do the derivative of f plus g, so I can split these up because it's addition, right? I couldn't do that if it was multiplication. I'd have to use that product rule. It's frigid in here now. So here I'm going to do the derivative at -3 plus the derivative at -3. So at -3, right, that's 3 over 2. Plus the derivative of g at -3 would be 0. So this would equal, whoa, oh no, I don't have an undo on here. Okay. Back to red. Yes. Well, look at what it asked me. It asked me for the derivative of the two added together. So it's 3 over 2 plus 0, which is 3 over 2. Because of this little dash above there, yeah. What's wrong? Okay, which part's not making sense? Part B is not making sense? Okay, so for part B, they're asking me for the derivative added together. So I broke that apart because addition I can break apart. So derivative of f at -3. So if I go to -3 on f, the derivative at this point is the slope. Because this is not the graph of the derivative, this is the graph of the function. So the derivative f prime of -3 is going to be 3 over 2. Instead of the derivative. Well, they're flipping back and forth, so look at C. C asked me for f times g at 1. So I'm going to do f of 1 times g of 1. Well, what's f of 1? $2.5, right. All right, so look at the difference in C and in D. The prime is the derivative, the regular. Are you freezing too? It's Wyatt's fault. F of 1. F of 1 is 2.5. G of 1 is, ooh, it's a little bit past though, isn't it? I'm going to say that's like negative 0.25. What does that give you? And let's see if we get the same thing they got. Somebody with a calculator. 6.25. 0.625. Oh, they got negative 1.25. I don't know what they use.
All right.
All right. Let's do part D. What's the difference in part D? It's the derivative. All right, I'm going to come up here and write it. So if I do f times g prime of 1, I'm going to have to do the product rule here. Okay, so y'all stay with me. Derivative of the first times the second plus the first times derivative of the second, right? Isn't this a product? And now I need to look at the point 1. So what is f prime of 1? Negative 1/2. What is g of 1? Negative 0.25. Or 1/4. Okay, I don't have an undo. F of 1. G prime. So derivative of g at 1. 3/2. Does everybody see how we're getting these? Because I feel like I got about a half of y'all. And the other half, I can't tell if y'all are bored or you're confused. I know. What? I think so too. It takes practice with them. It takes practice with them. So, Logan. To me about the problem. I know. No, you're not. No, you're not. You're having a full-blown conversation back there. And all I hear is like 100 miles an hour. Now, what did you say? These numbers come from, oh, I forget you can't see. Okay, here's the problem, right? All right, so I did the product rule. Derivative of the first times the second plus the first times derivative of the second. All right, so then f prime at, and it's telling me to do it at 1, right? So I go to f and I go to 1, and f prime, that would mean the derivative, which is the slope. So anytime it says derivative, that's slope. Well, that point, but you're looking for the slope, not the point.
Okay, so the derivative is slope.
Right.
And then g out.
And then g at 1, right. Plain old g at 1.
0.
Well, it actually goes down about 1/4. That's why we put -4.
Well, how do you know that?
Because see how it goes, g at 0, it goes down. I just guesstimated. It won't be exact now. Yeah. Right, yours will be obvious. Yours will be off. All right. Look at E and G. I mean E and F. Oh, I don't know. 1/8. I was gonna give you the rest of it for homework. 5/2, so that would be 15/4. Okay. Bring me the paper, I'll sign it. All right.
If Miss Montgomery signs off on it, yes, we can drop.
What's the reason to drop?
Can't drop. You can drop second semester, but you couldn't drop now. You'd have to drop FA now. It means a failure, like you due to absences. So you essentially you take absences for the rest of the year and you get a 0 for the class. Yes. It averages a 0 in on your GPA. All right, F of G of 2. Look. Look. Guys, this class would go a lot better if y'all would lock in and pay attention to me whenever I'm struggling to try to beg you to pay attention. All right, F of G of 2. I'm just going to write it that way. I think it's a little easier to see that way. Inside out. This is where it's a little different because chain rule I go outside in, but whenever I'm doing a composition of functions, I'm inside out. So G of 2 first. What is G of 2? 1. And what is F of 1? Yeah. 2.5. Now, here's where it's a little bit harder, and if you see it in this notation, I think it's easier to see here also, because I actually gave you this notation yesterday when we talked about chain rule. So I'm going to do the derivative of G of 2, and then I got to multiply by the derivative of G at 2. So this one I'm outside in instead of inside out, because it's chain rule. So I do the derivative of the outside function, but I keep, just like, remember whenever we do those power rules with the trig functions, we do the exponent, but we keep that trig function the same. We do the derivative, but we keep this inside the same.
So whatever G of 2
Yeah.
is.
So what is G of 2? 1. So I'm really looking for the derivative of F at 1. So I go over to F at 1, and you're right, because it's the slope, which is -1/2. And then the derivative of G at 2, positive. These I'm only looking at slopes at this point, because they're both derivatives. Yes. All right, so you got one just like that on your homework. That was number 60. See what else I got for you. We got 57 to 62. No. I can't decide if I need to do one of those with y'all or if y'all got that. Let's do 62 together. I know. How do I just get it all to go? Oh, is there an undo on here? The problem? So the first one, 2 times f of x at x equals 2. So I'm 2 times f of 2. Well, all I have to do is come up here to my table. F of 2 is, so 2 times 8, no. Oh, read the directions, Stacy. What's it say? Derivatives. So I'm finding the derivative of this. In the table, it gives the derivative, but it's saying evaluate the derivative. So it's saying find the derivative here when x equals 2. So the derivative at 2 is 1/3, and I have to multiply by that 2 that's in front, so 2/3. Do y'all understand? We're doing the same thing we did before. What do you mean? No, now you have to find, so they're saying find the derivative of this and tell me what it equals when x equals 3. So if I find the derivative of this, I can use the rules of derivatives that say, hey, I can do derivative of the first plus the derivative of the second. Yeah. Yeah. And if I'm going at x equals 3, now I'm using the table. So at 3, derivative of f at 3 is 2 pi. Derivative of g at 3 is 5. What's different about C? Product rule. So if I'm doing the f times g, but I'm doing the derivative of that, then I'm going to have to do the derivative of the first times the second plus the first times derivative of the second. At 3 or at 2? At 3. It's literally just looking at that table and pulling the correct values from it. Derivative at 3 is 2 pi. G of 3 is -4. F of 3 is 3. Derivative at 3 of G is 5. -8 pi plus 15. That gum nasty. We have to do what? Quotient rule. That's exactly right. So derivative of the top times the bottom minus the top, derivative of the bottom, all over the bottom squared. But now I look, where am I evaluating it? I'm evaluating it at x equals. So all of these are 2. And then I just use the table to go through and fill in. Welcome. I'm going to assume y'all can finish working that at that point. I want to make sure I can get all these set up for you because you'll have to do the same thing in 64, and I want to make sure you can set them up. They're easy though. How about this one? If I find the derivative of this, what does that look like? Yeah. Yes, ma'am. That's from the screenshot. It keeps confusing me too. How do I find the derivative of e? I have to do the chain rule. So I do derivative of the outside times derivative of e. And then I look at what point at 2. I love these. Now you just do what? Yeah. I would take the top and multiply by the flip of the bottom. How about f? Square root of f of x. 1/2, I'd do the exact same thing. I'd say, well, that's not really square root. That's that to the 1/2. Now do power rule. Power and chain, right? You see I got to do the chain. Chain, chain, chain. Nobody? And then chain it. You go at 2. G of 2 is 2. So then you'd have f prime of 2 times g prime of 1/3. Open the door. Good Lord. It is -1. 1/3 times -3. How do you know times what? That's that chain rule. So I do the power first and then the derivative of the inside. What's her? Ellen asked me about f. She asked me what on f, how it goes. For g, set it up. I got 1 over g of x squared. So really, I think if you write it like this, it's a little easier. I'd write that with a negative exponent. I didn't work it out. I just set it up. It should be for f 1 over 12 root 2. Oh my goodness. At 2, what? 1/2 f of 2. F of 2 is 8, but it's 8 to the negative 1/2. The derivative at 2, I don't think y'all can probably see that so good over that writing. Derivative of f at 2 is 1/3. Third. That's right. So this is 1/2. This is 1 over square root of 8. This is 1/3. I'd at least put them together. 6 root 8. If you're in a multiple choice situation, they're going to break that 8 up into 2 and 2. 2 root 2. Right? 1 over, yep, 12 root 2. If I come back over here to g, if I take the derivative of that, I got to do outside in. So power rule, which gives me what? -2 g of x to the -3 times right. derivative. Because it was 1 over that squared. This said 1 over, that's the way the original problem started. So I said that's the same thing as saying g of x squared. So instead of it being in the bottom, I just made it a negative. It's always easier for me, if it's a fraction, to take what's in the bottom and make it a negative exponent before I take a derivative, because quotient rule gets so messy. It'll save you a lot of time doing that. All right, challenge problem H. See if you can do it. I'm going to come off to the side with H. And y'all can go back and fill in the numbers. We only got 5 minutes left, so I want to make sure I get through walking you through the derivative on this one. So let me set it up here. H says the square root of f squared of x plus g squared of x. And it wants me to find the derivative of that. This one's kind of gross. I change all my radicals to exponents because it makes it easier as I do derivatives. So now I'm going to do power rule. We can't distribute it because you're adding inside. You can't do that. No. Y'all can be real jerks sometimes. Well, right. So whenever I do the inside, whenever I multiply by the chain, I am going to have, this is going to be like a double chain in here. All right, when I take the derivative of this, I get, what is the derivative first? I can split these up, right? So I can do the derivative of f squared of x plus the derivative of g squared of x. This is my first chain. Okay, but whenever I go to do the derivative of each one of these, and this splits up because it's addition, so I've still got this 1/2. I'm just rewriting that part here. What is the derivative of f of x squared? Do this too. That's right. I got to do the power, and then I have to chain it. Now I'm going to put these in brackets here because this is multiplied to all of this. So I've got 2 times f of x, but then chain it.
Good morning. Pardon the interruption, but this is a reminder that today during second log, all of Ms. Brunsell, Finnegan, and Hall students are to report to their class during second log.
Who's Brunsell?
Again, any first